So, event sourcing has built a reputation for being difficult. And there are reasons for that. You will usually find it in big applications that are complex. And not a lot of people have experience working with event sourcing and these systems in general. So it only makes sense that if you're going to put a team that hasn't worked with event sourcing and you put them straight away into a big and complex system, they will have some difficulties. So the first thing is keep it simple. It's true that event sourcing can be very useful in these large applications. However, there's other things that event sourcing can solve for us. A good example of this is in my last company called Axel Payments. We needed to have an audit about the things that happened in the application. Basically, we were doing financial products, so everything needed to be tracked. For that, we knew we could use event sourcing, and we did, and it solved that problem. Later, we found that not only it solved the problem of an audit, it also helped us structure applications and build our features faster. So event sourcing for us was not a difficult problem to solve, but rather than a tool that helped us solve difficult problems. So yeah, I want to say that event sourcing is not hard. It is just different, and if we learn how to use it, it can give us a lot of benefits. So what is event sourcing? It is a combination of two words. Event is a stored record of something significant that happened in the business. And sourcing basically means that our application state is going to be created from those events. So we can see here that we have a user. They will be creating an event that will get stored to the event log. Then it will get processed, and our state will be created. CQRS is a principle that goes well with event sourcing. Basically, it says that we should have two types of state, a command processing state and a query state, or otherwise known as the read model. So basically, it works like so. On the command processing side of things, you can have your application interface that is going to be creating commands. You can then send those commands to the command processing state, and it will create your events. Those events can be stored to the event store, and they're also going to be used to update the command processing state. Then, once you have your events, you can listen to those events with your event handlers, and you can create your read model that then you can feed back to your application interface. So basically, you have this loop where you create commands in order to create events, and then you can use those events to create a read model that you can later use to build up more commands. So what we're going to be doing today? Well, we're going to be building a bank with Commanded. Commanded is a library that for event sourcing and CQRS in Elixir. It provides with a lot of powerful abstractions, and what I like about it is that it will not get in your way when you're trying to model your application. So we're going to have some requirements. We want to be able to open accounts, to deposit and withdraw money, view account balances, transfer money between accounts, and while doing all of this, we want to keep track of our accounting. So the first thing we usually want to do in an event-sourced application is to get an idea of what are the events that we're going to be having in the system. In our case, we want an account to get opened, money to be deposited, money to be withdrawn, and money to be sent to an account. Then we can put our commands. So we're going to have a command to deposit money, one to withdraw money, and one to send money to an account. Now, we will not have a command to open the account, and that is because we have as a business requirement that when we are going to be depositing money for the first time, we also want to open the account. So next, we want to identify our business entities. In our case, we're going to have an account. And next, what I like to do is wrap all those things together in a context. We'll call this the accounts context. We also wanted to keep track of our accounting. So we're going to create an event to just that. And we can create a small subcontext that can have like one event called journal entry created. Next, we're going to be defining some types. Basically, we're going to be using these across the application. So we have an account number that is just a binary, an amount that is an integer, and account entries that is a map that the key is an account number and the value is an amount. In our application interface, we're just going to list out the actions we want to be able to do. So we can deposit money, withdraw money, send money, and view the balance. Next, we want to structure our commands. We will structure these as Elixir structs. Basically, we can see that we have two commands here, the deposit money and withdraw money. And both of them have an account ID and an amount. I'm typing these commands, and in general, I'm going to be using types because I feel it documents better the code. So next, we have our events. We have our money deposited, money withdrawn, and account opened event. And our journal entry created event. Basically, this is a little bit different than the other ones that had an account ID and an amount. This one has a journal entry UID, and then we have a debit and a credit, which is basically that accounting entries type we defined earlier. It will look something like this. Now, this is not very important, but we just need to know that we're going to be using this event to keep track of our accounting. So next, now that we have our commands and our events, we want to build our business object. Basically, it's called an aggregate in commanded. So as you can see, this is very similar to in CQRS, we saw like the command processing state. This is basically that. We're going to have an application interface that we're going to be creating command, and then we are going to use a router to dispatch them to an aggregate. And that aggregate can validate these commands, and it will create events or return errors. And then it can use those events to update its state. Our router will look like this. We are basically using commanded, and it will provide us a dispatch macro. That we can use to basically say that we want to route the deposit and withdraw money commands to our account. And we're going to use an identity. That identity must be included in our commands. And basically, it exists because we're going to have multiple instances of the accounts. You can think of the account as the aggregate type, and then you can have many instances of that aggregate. So this is how our aggregate looks like. Basically, we can see that we have a state. And what I want you to notice is that if you would initiate this struct, it would start with an ID as nil. And then we have two callbacks. The execute callback is used to validate commands and create events. It takes the state of the aggregate as the first argument and the command, and it will return the events or an error. Next, we have our apply function, which also takes the state, but this time it will take an event. And it will just return the updated state of the aggregate. Basically, the events that are going to be returned in the execute are then going to be used in the apply to update our aggregate state. So moving to our business logic. As a first thing, we want to say that when we receive the deposit money command and it has an account ID of all zeros, we want to raise an error. That is because we have as a business requirement that this account is reserved by the bank and we don't want it to be used by anybody else. Next, we're going to say when you deposit money and you just initiated the account, you want the account to be opened, money to be deposited, and a journal entry to be created. Next, when we're going to receive any other command and the account was just initiated, we want to say that it was not found. Basically, we're trying to send a command to an account that hasn't been opened yet. And then when we deposit money to an already open account, we will deposit the money and create a journal entry. So on our withdrawal, we're going to say when somebody's trying to withdraw the money and you have you don't have enough of a balance, return an error that you have an insufficient balance. And otherwise, you can return the money withdraw event and the journal entry. Now, we can see that we're going to be using the apply to basically update our state. And we can see that on the account opened, we are setting the ID. That is why later it will not be nil, and we know that the account has been opened. Basically, the first time it's going to receive that deposit command, it's going to return this event that will set the state in the latter commands. And then when we deposit the money, we want to increase our balance, and when we withdraw the money, we want to decrease our balance. On our journal entry created event, we don't want to change the state of this aggregate. We're going to be using it for a different thing. Then, in our application interface, we can basically construct these commands and just dispatch them through our application. This application is like the commanded application. I'm not putting all the details because I wouldn't have time for it in this talk. But basically, you will have an application that you can use to dispatch the commands. And what I want you to note here is that we are returning this execution result. This is also something provided to us by commanded, and we will later see how it actually looks like. So now, viewing the balance. Now we have some events. We can have some events in our system. So we want to handle those events and create a read model that we can then query. Basically, to do that, we're going to use a concept called a projector. This is an event handler that returns an ectomulti that then it will also execute. So basically, all the side effects that will happen in this projector are going to happen in a single transaction. It also gives us some guarantees that it will not basically, it will not handle the event more than once. This is because of how messaging works. However, we can know with the projector that it will only handle an event once, and we don't have to worry about an event being handled more than once, or like the side effects. At least as long as it's in, like the side effects are inside the ectomulti. So for our read model, we're just going to be using an ecto schema. This should be familiar to all of you. It's just an ecto schema, and we are defining it. Yeah, we're using the credit and debits as integers, and basically every row on our journal entry created event will create a single account entry. So from every event, you can have at least 2 accounting entries. So our projector is going to be structured like this. We have a project macro that is also provided to us by commanded. Then we want to use it to match on the event we are interested in. In this case, it's going to be just our journal entry created event. And then we want to use a callback, and basically give it, like it's a function callback that we can use as the third argument. And inside, we're going to receive a multi, and we're just going to insert many account entries. So with our projector in place, we can go back to our application interface and just write a query to view our balance. So let's try it out. In our IX session, we can try and deposit the money. So we're going to try to deposit 100 to the account 101. And we can see that we now have a state. The state is updated, and we have a balance of 100, and we have the account number there as in the ID. And we can see that the events we expected got created. Like we have an account opened, money deposited, and a journal entry. Next, we will deposit another 100, and we can see that the balance is now 200, and that we have 2 more events that got created. Money deposited and journal entry created. Then if we withdraw money, we can see we're going to withdraw 200, so our balance is now 0, and we have more events in the system. And then if we try to withdraw even more money, we can see that now it will return an error because we don't have enough of a balance. If we try to withdraw money from an account that doesn't exist, well, it will tell us that it doesn't exist. And we can use our query to view the balance. Now, this basically will not look at the aggregate state, but rather it will look at that read model we created. That is quite different from how the aggregate state actually looks like. So now to transfer money. To transfer money, we need to basically send money from one account to the other. And to do that, we have to decrease the amount that one account has and increase the other. However, they are independent processes in our system. As I mentioned, we will have multiple instances of these accounts, and they don't necessarily communicate with each other. What I mean is, like, in theory, you could make them communicate, but you might lose information from those messages. So basically, you want to always communicate through events. And to do that, we can use something called a process manager to help us basically communicate between aggregates. What it does is that it will read events and it will create commands out of them. And you can think of it as a mix between an event handler and an aggregate. Like in an event handler, it will read events and do a side effect, which is going to be dispatching commands. And then, like in aggregate, we're going to have multiple instances of process managers, and they're going to have a state. So basically, we can use our process manager to create a process like this. When we send money, then we wanted the money sent to account event to be listened by our process manager, and then we want to receive the money on the other account. So let's go ahead and do that. So we're going to create one more command to send the money. It's going to have a from account ID and a to account ID and the amount. Then we want to create a money sent to account event. And here, in addition to those 3 basically parameters, like from account ID to account ID and amount, we're going to have a transaction ID. And we're going to be using that for identifying like this whole transaction. We want to be able to identify the receiving and sending money as part of one thing. So we want like a unique like a common identifier. And another thing that we'll be needing to use this is we are using journal entries in our system. And for that reason, we always need to increase and decrease something. And we're going to use this ID to temporarily put the money in the transaction while it's being moved. That way we can ensure that even if for some reason it failed, the money would be able to be tracked down. So in our router, we're going to dispatch this new command, and we're going to say that the identity this time is the from account ID. And in our aggregate, the business logic will be that if you don't have enough of a balance, return an error. Otherwise, the money gets sent to the account and decrease your balance. And on the receiving side, we also have the transaction ID, from and to account ID, and the amount. The event the same. And in our router, it's also the same, but this time the identity is the to account ID because it's the other account. And when we're going to be receiving the money, we're going to say that the money got received from the account and that the journal entry got created. And we're going to increase our balance. So now the process manager. So the process manager, you can think of it a little bit as an event handler. It's going to be handling events. But it also has a state that you can update. We're not going to be needing the state much, so we're going to use the transaction ID as the state, but we're not really going to be using it in this process. Then we have an interested callback. Basically, that is used for three things. First, it helps us. It will tell the process manager which events are you interested in. What are the events that you want to handle? Then you can see that we're returning a start and a stop. Basically, process managers have a life cycle. Preferably, you would start a process and then you would finish the process. So it's usually best when you model process managers in a way that they have a stop at some point. In our case, when the money is received, we can stop the process manager. And when the money is sent, we are starting it. And finally, that ID will identify the instance of the process manager, as there are going to be multiple. Basically, for each transaction, there's going to be a different process manager. So then the money, like when we receive the money sent to account event, we want to construct the receive money from account command, and a command that will automatically dispatch it for us. So, and then we're just setting the state, but as mentioned, it's not really used. And then we can try it out. We're going to be depositing money to the account 102 and the account 103. And we can see that both of them have a balance of 100. Then we're going to be sending money from, basically I can't see it, but like I'm having the account 102 and the account 103, and I'm using the send money command from our application interface. And we are sending an amount of 50. And we can see that the balance got decreased to 50, and so our state got updated, and we have two events. And then if we look at the balances, we can see that both increased. Now you might wonder why is that, since we only received these two events. The thing is that when sending a command to an aggregate, we will only see the events that itself got emitted. So if we have a process manager, it will create events in the background. So if we basically check our 4 last events that are in the system, we can see that we both send the money and receive the money. All right, but we have a problem here. What if we are trying to send money to an account that doesn't exist? So as we mentioned, we are when we are sending to an account that doesn't exist, we were going to get an error. And and while we receive the events that the money got sent, it will never get received because that account doesn't exist. So now we have received the balances. We have the balance of 0, which is actually incorrect, or you can say it's correct since the money got sent, and the other balance is nil. Luckily, the way we constructed our we have like the transaction ID that we can see that the money is stuck there. So we had a process like this. Now we need to create a process to basically handle the failure. So we're going to say when you receive money and the account ID is nil, we want the money received from account to get failed, and then we want to fail the transaction. Now you might think that this will require a lot of changes and a lot of code. However, it actually event sourcing can make it kind of this would look like the whole process, right? So yeah, you might think that it will complicate things a lot and that we might need to make a lot of changes. However, the good thing about event sourcing is that usually creating new paths in our flow, in like business flow, you don't really have to make a lot of changes to the old ones. So what we're going to be doing is that we're going to say that when you receive money from an account and the account ID is nil, the money received from account will fail, basically. So we're going to return that event. Now we have to put this function cause above the other one causing the error, obviously, but now we will be creating this event whenever we receive money for an account that doesn't exist yet. And we're just going to say that we don't need to really change the state because it's going to be an account that doesn't exist anyway. So next, in our process manager, we're going to be interested in two more events. In our money received from account failed and the money transfer failed. For one of the two, we're just going to say that to continue the process, and then we're going to be handling it. And we're going to say when you get this event, fail the money transfer. And for the other event, we're just going to be stopping the process manager because once we receive that event, we know that the process finished. And then in our back to our account, we're going to say when you fail the money transfer will get failed, and you're going to create another journal entry and increase your balance. To basically, you decrease it when you send it, so when it fails, you're going to increase it again. You're going to increase it this time, yeah. And it's fixed. So the good thing about this is that we actually, after implementing this code, we can restart our application and it will automatically get fixed. That is because our event, basically the process manager runs in the background, and as long as it fails, it's going to try to rerun that event. So once we solve this business case, basically it can continue its process and finish what it started. And that's it. So today I tried to convince you that event sourcing is really not that hard. And in general, like my opinion is that it's very often used in systems where it's either not required or you have like a team that's not ready to work with it yet. And for that reason, I would say that if you're starting to do something in event sourcing, just pick a small piece of your application and use it when you know it can solve a problem for you. Don't make event sourcing a problem to solve, but rather use it to solve problems. So yeah, I hope I maybe inspired somebody to go out and try event sourcing. And yeah, this is it. Thank you. Yeah,
thank you.
Do you have time
we
for
have
questions?
some time for some questions. So if you have any question, please come here. And in the meantime, I'll read one from the online audience. So which strategy would you suggest for implementing GDPR compliance with commanded? For example, how to handle the right to be forgotten, considering that events should be immutable?
That's a good question. So basically the question is, how do we handle GDPR? The thing is that GDPR says that we should not store sensitive data of our users, or in general, not sensitive, like personal data. So in my opinion, you don't ever need to store personal data in an event. Usually you can, let's say that you have a user email. What you can do is you can, instead of storing the email, you can have an event that a user got registered and just mention that user UID. Then you can have all the information regarding that user somewhere separate. In general, I think you don't need to use event sourcing for something that is not your core domain. And it can be that user personal data is your core domain, but usually it isn't. So just don't store it. Store it somewhere else and not in the events.
Thanks. We'll take one from here right now.
Hello. So practical question about, so why cannot we, for example, check if second account exists in a command handler? So before we will create any events.
So yeah, we could do that. And there's a lot of features in Commanded that I didn't go through. The thing is, if we would check it in the command handler, we would need to rely on something like a read model, right? And let's say that we have a business logic where we would be able to close the accounts. Then you have this case that the account might get closed just before you send out the command. So you will get your read model, which is eventually consistent, and then at the point you want to, like you verify that that's the state, and then the state changes under your feet, basically. If a process manager is used correctly, it will create its own state from those events. So then it always knows what the correct state is. So for example, if we would be able to close accounts, we could have the state representing that in that process manager. And then if somebody would close the account, we would just read it and update the process manager state.
Okay, so basically we cannot access any read models from command handler, correct?
So
it is not desirable.
So what I would say is it depends on your domain. Let's say that you know that something that will probably not change under your feet, like the chance of it changing under your feet is like once in a billion. Then probably you don't need to go through like this whole extent. So basically, I think in event sourcing, you have to know your domain well and understand what is possible and what is not. And if something is more likely to happen, then maybe it's worth kind of making it very rigid. But maybe if like the risk is not that big and then the harm is not that big either, you can get away with just using the read model. So it depends on your domain. Like for example, like if there is a chance, even 1 in a billion, that somebody will lose a lot of money, then maybe you don't want to take that risk. But if it's just such a chance that somebody might need to refresh the page, then like it's fine, right?
Okay, thank you.
Hi, thanks for the talk. Actually, I have two questions, if I may. One is, how would you deal with the event versioning? If, for instance, over time the events will actually change. And the second one is actually, how would you deal with the eventual consistency problem if, for instance, your read model is not available, or something like that?
So yeah, regarding event versioning, yeah, it's a bit subject. I haven't used event versioning. Like I have a case where I tried it, but I didn't have a big business need for it. Usually what we would do is that we had basically updated our events, but we didn't keep the versioning. And we used something called an upcaster in Commanded. And an upcaster, basically you will read the event, and after you read, you transform it, and then you pass it to all the event listeners. So basically we would use that whenever we updated an event. And yeah, it's like a big thing. Like Ben Smith has been experimenting with it a little bit, and I see that now in like his examples, he always includes a version in the event. But basically in the struct that we saw, you can include a version and then you can match on it. So then you can say, okay, when the version is version 1, handle it this way. When the version is version 2, handle it this way. So you would have like different ways of handling, and you would like leverage pattern matching to do that. And regarding eventual consistency, yeah, that's the thing. Like that's why you want to use things like a process manager, or that's why the aggregate state exists in the first place, why aggregates exist. So you can basically don't have to deal with eventual consistency. Where you might want, what I mean, like you're always going to have the eventual consistency in the read model, and that's something that it depends. Like, you'll have to deal with it. Like, if for example, you cannot access your database, well, this could have happened if you were using a regular database and if you weren't using event sourcing and your database went down, like, it's the same problem, right? So yeah, but you could. The good thing about event sourcing is that the events are the core of your data. So basically, you could create many read models, right? You could have the same read model in multiple databases, and it makes it easier in event sourcing than in other system where you would have to maybe once in a day create, or I don't know how exactly you would go about it, but in event sourcing you can create many replicas of the read models because it's just very easy for us to do it.
Okay, we have one more from the app. Is event sourcing suitable only for financial apps? If not, what other use cases we can use?
So in general, I would say event sourcing can be good everywhere. However, I think there should be a limited scope to the things you need it for. So yeah, I think any place where actions happen. So basically, you can think about it as so. So when you have a business, you have important things that happen in the business. As long as you store and you care about only those important things that matter to the business, then event sourcing can be applied, and it will gonna be successful. It's gonna give you value. But maybe you don't you shouldn't overuse it and use it for things that are not part of the core domain of your business. And yeah, there are gonna be cases that it's probably not required, but I would say that almost everywhere, yeah, if you can apply domain-driven design and you can think well about your domain and you can create domain events from it, then event sourcing is gonna be useful.
Okay, the last one. When replaying events that rely on external queries, it seems it's not 100% guaranteed that the application state can be rebuilt accurately since the external data can change. How we can handle that?
So in that case, I would store the external data among the event. If you're gonna have a dependency on some, yeah, the thing is we mentioned that if it's in the event handler. So maybe what you want to do instead is in the event handler, the first time you query that resource, to create a new event with that data. Or otherwise, you're gonna have to depend on that external data, and either you're gonna store it in your events in a new event, or you're gonna have to make sure that you don't lose that data.
Okay, thank you. Give him another round of applause.